Hello everyone, in this video we're going to explore topic 8.7 and 8.8. Find the volume of the solids using the cross sections, squares, rectangles, triangles and semicircles. Alright, you look at the figure right here. Alright, this one is the 3D figure. Kaufman Center for the Performing Arts in Kansas City. Alright, and you observe that the cross section right here is the semicircle. They are repeating and getting bigger and bigger, right? The AP calculus exam will focus on 4 familiar shapes from geometry: the square, the rectangle, the semicircle, and several variety of triangles. Right? Now, if you have the square, in order to calculate the area of the square, does that mean you need a side length, right? So the area is side square, right? The rectangle, you need the length and the width, and the area is going to be length times width, right? The semicircle, you need the radius, right? Then the area is pi times r squared. Now the triangle, unit, base and height, right? Then the area is 1/2 base times height, right? Now equilateral triangle, you learn in geometry. Now suppose the equilateral triangle has the side A, right? So this guy is A, this guy is A, and this guy is A, right? In order to calculate the area of the equilateral triangles, you need to draw the altitude, right? So the area is 1/2 base times height, right? The base is A. The height is not given. We need to calculate the height. So how do we calculate this one? We're gonna use the special right triangle, right? So this one right here actually 60 degrees. Right? This one right here actually 30 degrees. Right? The side length opposite to 60 degrees equals the side of the triangle times √3 divided by 2. So we're going to substitute over here 1/2 times base. The base is A right here. Times the height is going to be right here. A √3 over 2. Right? Now we're going to simplify this one. It's going to be A square √3 over 4. Right? So make sure you know this formula. Now, isosceles right triangle. If this one A, this one should be A. Right? This one is the right angle, right? So the area is 1/2 A squared, right? Base equals A. The height is still the same, right? Now, to find the hypotenuse right here, I call the hypotenuse S, right? I'm going to use Pythagorean theorem. So I have S squared equals A squared plus A squared, right? So it could be 2A squared. Take square root both sides. S equals A √2. Keep that in mind. Alright. The volume of the solids with known cross sections. Cross sections of area A of S taken perpendicular to the x-axis. This is extremely important. You have the volume equals the integral from A to B of A of S, right? This one is the area of the cross section ds. Make sure this guy and this guy must be the same, right? Now for cross sections of area A of Y taken perpendicular to the y-axis, and then you have the volume is the integral from C to the A of Y dy. This guy and this guy must be the same, right? Now let's take a look at this table right here. Suppose I have the x and y coordinate right here, right? Now suppose I have two functions. The first function is going to be like this. The second function is going to be something like this. Alright. Now I need to calculate the volume of the solid where the cross-section is perpendicular to the x-axis, right? And the cross-section is the square, right? So it's going to be something like this. Alright, and you keep drawing the square. Then the solid should be something like this. Right? You know that the side length of the square is right here. Right? It's going to be upper function subtract the lower function, right? The upper function right here, I call this is yt, which means y top. The lower function right here, which means y bottom, right? So x right here is y top subtract y bottom, right? Then the error is x squared or y top subtract y bottom all together square, right? Now, in order to calculate the volume of the solids, you need to calculate the integral from a to b, right? This one from here is going to be a. This one right here is going to be b, right? Of x squared, actually this one is going to be y top subtract y bottom all together square, right? Similarly, the rectangle is going to be exactly the same thing, right? Base times height, right? The base is y top subtract y bottom. The height could be a constant or the function in terms of s, right? So depending on the problem, we're gonna take a look at the symbol later, okay? Now next one, the semicircle. Alright, diameter of the semicircle is the difference between the y top and y bottom, right? Then the cross section should be something like this. Now I'm gonna call the diameter of the semicircle d, right? D equals y top subtract y bottom. Makes sense. Now I need to find the radius. So does that mean the radius equals half of diameter? It's going to be 1/2 y top subtract y bottom, right? R square, right? Remember, in the first one right here, I let s be yt minus yb, right? So this guy does that mean it's going to be 1/2 s, right? Then the error is 1/2 pi r squared, right? Because this is the semicircle. Alright, so does that mean 1/2 pi r equal this one right here, right? So I'm going to square this one. So it turns out to be 1/2 pi times s squared over 4. That's why I get this one right here, right? Now, in order to calculate the volume of the solid, I'm going to use the formula right here, right? So, it's going to be the integral from a to b s squared ds. This one is the constant. I'm going to bring this one to the front, right? Again, s squared right here actually yt minus yb, right? The top function subtract the bottom function and then you square, right? Now, next one, equilateral triangles. We have the formula right here, remember? So, it's actually v equals root 3 over 4 integral from a to b of yt minus yb square ds, right? If you look at this one right here, the cross section should be something like this. Alright. Now let's move on to the next one, isosceles right triangle with leg in the base. Alright. The isosceles right triangle is something like this. Alright. This one is S, this one should be S, right? And this one is called the leg. Right? Now the leg in the base, so it's gonna be something like this. Alright, the right angle should be right here. Now the error is to be base times height, right? So base right here, height right here. Now the base and the height should be the same because this is isosceles right triangle, right? The length in the base, right? The base here. So the base is going to be the difference between two functions right here, y top subtract y bottom, right? Y bottom, right? And remember, this guy must be the same. So base times height is going to be s times s is going to be s squared, right? Or it's going to be 1/2 parenthesis y top subtract y bottom square, right? And when you calculate the volume, you're going to put 1/2 to the front, right? And the integral from a to b of this one right here, right? So it could be 1/2 integral from a to b of y top subtract y bottom all together square, right? Now we're going to talk about the last one, really, isosceles right triangle with hypotenuse in the base, right? So previously we know that the isosceles right triangle hypotenuse is s equals a root 2, right? Where's the length is a, right? So we go back over here. Hypotenuse is s, right? So we just say s equals a root 2, right? We look at the figure right here. Suppose this one is a isosceles right triangle, right? We have a root 2 right here equals y top subtract y bottom. Divide both sides by root 2 is going to be y top subtract y bottom divided by root 2, right? So the error is 1/2 y top subtract y bottom divided by root 2. This one is one leg. Another leg is y top subtract y bottom divided by root 2, right? Remember, s right here is y top subtract y bottom, right? So then you have 1/4 times y top subtract y bottom square, right? And it's going to be right here. Now the volume is going to be this guy right here. Substitute over here. Integral from a to b of s squared ds times 1/4, right? Now let's take a look at the first example. Find the volume of a solid in which the base is the region bounded by the graphs of this guy and this guy, right? So we need to sketch these two graphs right here, right? So this guy actually the linear function. I just rewrite this one as negative 1/2 s plus 1, right? So we have the y-intercept is 1, right? And then the slope is negative 1/2, right? So it's going down by 1 and go to the right by 2. So it could be something like this. Now the second one right here, I rewrite this one as 1/2 s minus 1, right? So if you grab this one, the y-intercept is negative 1, so it could be right here. Go up by 1, go to the right by 2, so it could be right here, right? And the third one, s for 0, this one actually the y-axis, right? So it could be right here. S equals 0, right? Now I need to name this one. This one is f of s. And this one is g of s. Alright. Now, the base is bounded by these three graphs, right? So this one is the base. Now, question 8. The cross sections perpendicular to the x-axis are square, right? So, you see that it's going to be something like this. The square. Alright, now you can use Desmos to visualize the problem. Alright, so I'm going to print it up right here. I'm going to leave the link in the description. Make sure you check it out. Alright, now I just changed the name of the function right here, f of s. Now f of s is negative 1/2 s plus 1 and g of s is 1/2 s minus 1, right? So you have f of s is negative 1/2 s plus 1, g of s is 1/2 s minus 1, and s was 0, which is the y-axis. Then you're going to scroll down, you need to restrict the domain, right? Domain is from 0 to 2. If you look at this one right here, 0 is right here and 2 right here is the intersection between two graphs, right? Alright, so x equal a equal 0, s equal b equal 2. So make sure you have a equal 0 and b equal 2 right here. Alright, since this one is the square, you need to calculate the side length of the square. Right, so does that mean this one right here? Right? So does that mean you need to take the upper one, subtract lower one. Upper one is f of s, right? So the sine equals f of s minus g of s, right? Now it's going to be 1 minus s over 2, subtract negative 1, which is you add 1, and then you change the sign of this one, it's going to be minus s over 2, right? So it's going to be 2 minus s, right? Now the volume is the integral from 0 to 2 of the side length square, right? So it could be 2 minus s altogether square ds, right? Now you need to expand this one, so it could be integral from 0 to 2 of 4 minus 4s plus s square ds, right? I use the complete square formula a minus b altogether square. It's going to be a square minus 2ab plus b square, right? So keep that in mind. If you have the plus side right here and this one's right here, must be plus side, right? Now I'm going to check antiderivative of this one, so it could be 4s minus 4 times s squared over 2 plus 1/3 s cubed, right? Evaluated from 0 to 2. Alright, now 4 divided by 2 is going to be 2 right here, so I need to erase this one. I put 2 right there. Alright, substitute 2 for s, so it can be 8 minus 8 plus 8 over 3. Substitute 0 for s, it could be 0, right? So the answer is 8 over 3. Now let's move on to the next one. The cross sections perpendicular to the x-axis are semicircle. Alright, so I'm going to use decimals. The semicircle should be right here. Alright, so I change the function right here. Now don't forget to change the upper bound and lower bound right here. Right, s for a, s for b. A equals 0, right? And b equals 2. Alright, so it can be right here. Look. So you have infinitely semicircle, where diameter is the difference between the function f of s and g of s, right? So I'm going to go back over here. So you know that f of s subtract g of s is 2 minus s, which is you calculated above right here, right? Now this one is diameter, right? So this one diameter. Now you need to find the radius. So the radius is 1/2 2 minus s, right? Now you need to calculate the area of the semicircle. So area equals 1/2 pi times r squared. R equals this one, right? So multiply by 1/2 times 2 minus s altogether square. Now I'm going to simplify this one. It's going to be 1 over 8. So it will be pi over 8 times 2 minus s altogether square, right? Now the volume should be the integral from 0 to 2 of this one right here, right? So it could be pi over 8, I put pi over 8 in the front, right? Times 2 minus s altogether square ds, right? This guy right here is 8 over 3, we calculate above, right? So it could be pi over 8 times 8 over 3, right? Now 8 and 8 cancel out, the answer should be pi over 3, right? Now question C, the cross sections perpendicular to the x-axis are rectangles whose the height are 3, right? So go back over here. The height is right here, is 3. The base right here is the difference between the function f of s and g of s, right? So the error is base times height. The height is given, right? So you have the base is difference between f of s subtract g of s. Keep in mind the top subtract the bottom is still 2 minus s, right? Then you have the error is base times height. It's going to be the height is 3 right here, right? So I multiply this one, it's going to be 6 minus 3s. the volume should be the integral from 0 to 2 of 6 minus 3s ds, right? Now I need to calculate this one, so antiderivative of 6 is going to be 6s, antiderivative of negative 3s is going to be negative 3 over 2s squared, evaluated from 0 to 2. Alright, substitute 2 for s is going to be 12 minus, substitute 2 for s right here, it's going to be 4 divided by 2, it's going to be 2, so it could be minus 6. Substitute 0 for s, it could be 0, right? So the answer is 6, right? Now let's move on to question D. The cross sections perpendicular to the x-axis are equilateral triangle, right? So again, the base is still 2 minus s, right? Because it's going to be different between f of s and g of s, right? Now since this one is the equilateral triangle, you know that the base is actually the side, right? So it's going to be, now the error formula of the equilateral triangles with the side A is going to be A square root 3 over 4, right? So you have the error of this one should be 2 minus s altogether square times root 3 over 4, right? So the volume should be the integral from 0 to 2 of 2 minus s altogether square ds, and I'm going to put root 3 over 4 in the front, right? Now this guy right here actually h over 3, we calculated above, right? So it could be root 3 over 4 times h over 3, right? So simplify h and 4 here, it could be 2, so it could be 2 root 3 over 3, right? Let's move on to example number 2, a circular base. Find the volume of the solid in which the base is the circle, center at the origin with the radius 2 units, whose cross-section are described right here. Alright, so first you need to write the equation of the circle with the radius 2, center at the origin, right? We have the standard form of the circle equation. It's going to be s minus h altogether square plus y minus k altogether square equals radius square, where h and k is the coordinate of the center, and the radius is square root of the number on the right hand side right here, right? Now the circle center at the origin, which is 0, 0, is the coordinate of the center, right? So which is h k equals 0 and 0, right? Now the radius is 2, so when you plug it in over here, you need to square because it's radius square, right? So I have s square plus y square equals 4, right? Now I need to solve for y. Alright, so I need to subtract s squared both sides, so y squared equals 4 minus s squared. Now I need to take square root both sides, so does that mean I have y equals plus and minus square root of 4 minus s squared, right? Now I need to sketch the circle, right? The radius is 2, so 2 right here. Alright, so you have the circle something like this. Now the upper semicircle is the one above the axis, so it could be right here. So the equation of this one should be y equals square root of 4 minus s squared, right? And the lower one is the red one, right? So it could be y equals negative square root of 4 minus s squared, right? The cross sections perpendicular to the x-axis are square, right? So you see the cross section is going to be something like this. Alright, so the side of the square is the difference between the upper semicircle and the lower semicircle, right? So it's going to be square root of 4 minus s squared subtract negative of square root of 4 minus s squared, right? So it could be 2 times square root of 4 minus s squared, right? you need to find the error of this square. So the error is square this one equal 4. Square this one is going to be 4 minus s squared. Now the volume is the integral from -2 to 2, right? From here to here. Of the error right here, right? It's going to be 4 times 4 minus s squared ds, right? This guy actually 2 times the integral from 0 to 2 of 4 times 4 minus s squared ds, right? Now 4 times 2 is going to be 8, right? Antiderivative of 4 right here is going to be 4s. Antiderivative of this one is going to be -1/3 s cubed. Evaluated from 0 to 2, right? Now I substitute 2 for s, so it will be 8 times 8 minus 8 over 3, right? Substitute 0 for s, it will be 0, right? So if I simplify this one, it could be 64 minus 64 over 3, right? And if you simplify this one, it's actually 128 over 3. Let's move on to question B. The cross sections perpendicular to the x-axis are semicircle, right? Now, if you sketch this one, it's going to be something like this. Alright. It looks like this one right here. But the base is the circle, right? Diameter should be this guy right here. The difference between the upper function and the lower function, right? So you still have diameter is going to be right here. Alright, so it could be 2 square root of 4 minus s squared, right? And then you need to find the radius. So the radius is square root of 4 minus s squared, right? Now you need to find the error. It's going to be 1/2 pi times r squared, which means 4 minus s squared, right? Because you square this one, it's going to be this one, right? Now the volume is going to be the integral from -2 to 2 of this one right here, right? So 1/2 pi, I'm going to put in the front pi over 2. So I have 4 minus s squared ds right here, right? Now this one turns out to be pi over 2. Alright, so this one is symmetric about the y-axis, so this turns out to be the integral from 0 to 2 of 2 times 4 minus s squared ds, right? So this guy turns out to be pi times the integral from 0 to 2 of 4 minus s squared ds. And then this guy turns out to be pi times 4s minus 1/3 s cubed, evaluated from 0 to 2. Substitute 2 for s, it will be pi times 8 minus 8 over 3. Substitute 0 for s, it will be 0, right? So this guy turns out to be 16 pi over 3, right? Now let's move on to question C. The cross sections perpendicular to the x-axis are equilateral triangle, right? So you know that the side length is going to be different between the upper function and the lower function, right? So the side is 2 times square root of 4 minus s, which you calculated above, right? And the area of the equilateral triangle should be 2 square root of 4 minus s squared right here, all together square times root 3 over 4, right? Now 2 square equals 4, 4 and 4 right here cancel out, right? This one square equals 4 minus s squared, right? So I have 4 minus s squared, right? I need to multiply by root 3 right here, right? The volume is the integral from -2 to 2 of this guy right here, right? So I put root 3 in the front times 4 minus s squared ds, right? Again, since this one is symmetric about the y-axis, right? So it will be root 3 times 2, right? Integral from 0 to 2 of 4 minus s squared ds, right? So it could be 2 root 3. Antiderivative of 4 is going to be 4s. Antiderivative of this one is going to be 1/3 s cubed, evaluated from 0 to 2. Substitute 2 for s is going to be 2 root 3 times 8 minus 8 over 3. Substitute 0 for s is going to be 0, right? So the final answer is 32 root 3 over 3, right? Now question D. The cross sections perpendicular to the x-axis are a isosceles right triangle whose hypotenuse reside along the base. Alright? So I'm gonna sketch the function again. It's gonna be right here. Right? The hypotenuse reside along the base. So this one hypotenuse right here. This one is a isosceles right triangle. Alright? So it could be something like this. Alright, and if you keep drawing, it's gonna be something like this. Now you need to calculate the area of one isosceles right triangle, right? So we have the formula right here. We calculate it above. It's right here. Hypotenuse in the base, right? It's gonna be 1/4 s squared, right? So area is 1/4 times s squared, where s is the difference of the upper semicircle and the lower semicircle, right? So it could be 1/4. Now, to get rid of confusion, right? So I just change this one to A. So it helps you, right? Where A is the difference between this guy, right? Remember y equals square root of 4 minus s squared. This one is y equals negative square root of 4 minus s squared, right? I take this one and subtract this one. Doesn't mean I get 2 times this one, right? So it could be 2 times square root of 4 minus s squared all together square, right? So if I square this one, I get 4. 4 and 4 cancel out, right? So this one turns out to be 4 minus s squared, right? So the volume is the integral form negative 2 to 2 of 4 minus s squared ds, right? And then this guy turns out to be 2 times the integral from 0 to 2, right? 4 minus s squared ds. Take antiderivative of this one, so it could be 2 times 4s minus 1/3 s cubed, evaluated from 0 to 2. Substitute 2 for s, so it could be 2 times 8 minus 8 over 3. Substitute 0 for s could be 0, right? So this guy turns out to be 32 over 3. Now, the next one, the cross sections perpendicular to the x-axis are isosceles right triangle with a leg residing along the base, right? In the previous one right here, you have the right angle should be right here, right? Now, for this one, I'm going to draw another picture right here. A leg residing along the base, right? So this is the leg. Another leg should be somewhere right here, right? So you have the right angle right here. You see that? And hypotenuse should be like this, right? And you keep drawing. And you know that the side length of the leg is the difference between the upper function and lower function, right? It's gonna be this guy right here, subtract this guy, right? Alright, so it's gonna be 2 square root of 4 minus s squared, right? Alright, now since this one is an isosceles right triangle, right? So which means this guy right here and this guy right here must be the same, right? And a leg residing along the base. So this is the leg right here, the leg right here. Alright, so the error is base times height divided by 2, right? 1/2. Base is 2 times square root of 4 minus s squared, right? And the height is going to be same thing, right? This one is the base. The height is right here, right? Because this one is an isosceles right triangle, right? So you need to multiply by 2 square root of 4 minus s squared, right? Now if you simplify, it's going to be 2 times 4 minus s squared, right? Now the volume is the integral from -2 to 2 of 2 times 4 minus s squared ds, right? So this guy turns out to be 2 times the integral from 0 to 2 of 2 times 4 minus s squared ds, right? 2 times 2 is equal 4, right? Now take antiderivative of 4 is going to be 4s. Antiderivative of negative s squared is going to be negative 1/3 s cubed. Evaluated from 0 to 2, right? Now it's going to be 4 times 8 minus 8 over 3, right? And then it's going to be 64 over 3. This one is the final answer, right? Now let's move on to example number 3. An irregularly shaped base. An irregularly shaped base. Find the volume of the solid in which the base is bounded by the curves y equals s plus 1 and y equals e raised to the s over 3, right? So we're going to wrap this one right here and this one right here on the calculator, right? So you're going to hit add graphs right here. The first function is s plus 1. Hit enter. Now you're going to enter the second function. So hit tab. It's going to be e raised to the s over 3. Alright, so it's going to be right here. Now the intersection right here is s equals 0, y is equal 1. We need to find the intersection right here, right? So we're going to hit menu, analyze graph, number 4. Move to the left, move to the right. It's going to be right here. 5.71 and 6.71, right? Alright, question A. The cross sections are semicircles perpendicular to the axis, right? So we just draw the semicircle, right? So it could be something like this. So diameter is the top subtract the bottom, right? So you have y top subtract y bottom. It's gonna be s plus 1 subtract e raised to the s over 3, right? Now you need to find the radius, so you need to divide this one by 2. So I have 1/2 times s plus 1 minus e raised to the s over 3, right? Now you need to find the area of the semicircle, so a equals 1/2 pi times r squared. So it could be 1/2 pi times this one square is going to be 1 over 4, right? Times s plus 1 minus e raised to the s over 3 all together square. Now 1/2 times 1 over 4 is going to be 1/8 times pi. It's going to be pi over 8 right here. Right? Now the volume is going to be the integral from the left endpoint is going to be 0. The right endpoint is going to be 5.71, right? So it could be 0 to 5.71, right? Of pi over 8 times s plus 1 minus e raised to the s over 3 all together square ds, right? Now we're going to bring up the calculator to calculate this one, right? So you're going to hit add calculator. Now press menu, calculus, integral from 0 to 5.71 of pi over 8. So you're going to press the button next to number 9 right here. Hit fraction. Pi over 8. times s plus 1 minus e raised to the s over 3 square ds. Hit enter. The answer is 1.981, right? Alright, the cross sections are semicircles perpendicular to the y-axis. Alright, so question B similar to question A. The only thing different right here is this one is the s-axis, right? Now we're gonna sketch the figure, right? Alright, now you need to rewrite every single thing in terms of y, right? Now the function y equals e to the s over 3. You need to rewrite this one in terms of y, right? So you're gonna take natural log both sides. So it could be natural log of y equals s over 3, right? Then I'm gonna multiply both sides by 3. So s equals 3 times natural log of y, right? Now for this one right here, I need to rewrite this one in terms of y. So s equals y minus 1, right? Diameter is s right subtract s left, right? This one right here, s right. This one right here, s left, right? Remember, when you calculate the diameter in question A right here, you need to take y top subtract y bottom, right? So this guy turns out to be 3 natural log of y subtract y minus 1. Now I'm going to simplify this one, so it's going to be 3 natural log of y subtract y plus 1, right? Now the radius is half of diameter, so it can be 1/2 times 3 natural log of y minus y plus 1, right? Then the error is 1/2 pi r square, r right here. So it's going to be 1/2 times 3 natural log of y minus y plus 1 all together square, right? So if I simplify this one, it's going to be pi over 8 times 3 natural log of y minus y plus 1 all together square, right? Now the volume is, since this one is in terms of y, right? So you look at the y values right here, right? The lower bound is 1. The upper bound is 6.71, right? This one right here. So it's going to be the integral from 1 to 6.71 of pi over 8 times 3 natural log of y minus y plus 1 all together square dy, right? Now you're going to bring up the calculator, right? The integral from 1 to 6.71, right? Of pi over 8 times 3 natural log of y minus y plus 1 all together square. Don't forget dy right here, right? Hit enter. The answer is 1.981, right? So which is the same thing as this guy right here. Alright, now let's move on to question C. The cross sections are isosceles right triangles with one leg in the regions perpendicular to the y-axis. Alright, so we're gonna sketch the figure again. Right, if you do the right thing, it's gonna be something like this. Now sink one leg in the region. So then this guy right here and this guy right here must be the same, right? Now the leg right here is difference between S right subtract S left, right? So it's gonna be right here. Alright, so it could be 3 natural log of y minus y plus 1, right? This leg actually the base, right? Right here. Now the height should be the same, right? So the height is 3 natural log of y minus y plus 1, right? Because this one is an isosceles right triangle, right? So the error is 1/2 base times height, which is 1/2 of this guy the same, so it could be 3 natural log of y minus y plus 1 all together square, right? So the volume should be the integral form 1 to 6.71, right? Because this one in terms of y, right? Now I'm gonna bring up the calculator. So this one right here should be 1/2. Enter. It's gonna be 2.52, right? And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.